Hello everyone, welcome to the SQRT channel. In this channel, we talk about math competitions and problems that are very interesting. For this problem, we have a set of equations. The first one is x cubed plus y cubed is equal to 1, and the second one is x to the power of 4 plus y to the power of 4 is equal to 1. We are going to solve this set of equations in real numbers. Before moving forward to talk about the solution, make sure that you pause the video to think about this problem. We are going to solve this problem in a systematic way. First, we are going to find the range of values that we can have for x and y. To do this, consider x to the power of 4. Since 4 is an even number, x to the power of 4 is going to be a positive number. It can be 0 as well. We can write y to the power of 4 as 1 minus x to the power of 4. Since x to the power of 4 is a positive number, then 1 minus x to the power of 4 is going to be less than or equal to 1. And this means that y is between negative 1 and positive 1, including those numbers. Now we are going to do the same thing for x. Since x to the power of 4 and y to the power of 4 is symmetric for x and y, we can also conclude that x is also between negative 1 and positive 1, again including those numbers. For section 2, from the ranges that we found for x and y, we are going to find what possible solutions we can find. First of all, x and y are both between negative 1 and plus 1. Let's focus on x is equal to 1 for now. If x is equal to 1, obviously y is going to be 0. And on the other hand, if y is equal to 1, then x is going to be 0. Now the question that we need to answer is, between these two solutions, are we going to have any other solutions or not? We are going to tackle these in the next few minutes. Now let's move on and see if we can find any other possible solutions for the equations that we have. We are going to start with x to the power of 3 plus y to the power of 3 is equal to 1. And for now, let's assume that x is between negative 1 and 0. If x is between negative 1 and 0, then x cubed is going to be negative 1 and 0. And if we multiply x to the power of 3 by negative 1, then negative x to the power of 3 is going to be between 0 and 1. Or 1 minus x to the power of 3 is going to be between 1 and 2. And remember, 1 minus x to the power of 3 is going to be y to the power of 3. So y to the power of 3 is going to be between 1 and 2, which is wrong, because we know that y to the power of 3 is going to be less than 1. So basically this means that x cannot be between negative 1 and 0. Since x and y are symmetric in these equations, we can find that both x and y are going to be between 0 and 1. Remember, since we already captured the equality for these equations, we are not going to target those from now on. Now we know that x and y are both between 0 and 1. This basically means that if we do this x to the power of 4, we are going to end up with x to the power of 4 is less than x to the power of 3. And obviously y to the power of 4 is also less than y to the power of 3. If you add them together, we will end up with x to the power of 4 plus y to the power of 4 is going to be less than x to the power of 3 plus y to the power of 3. And remember, both of these values were 1 in the original set of equations that we have in the problem. So this cannot be true as well. And it basically means that the values that we found at the beginning of this video, or x is equal to 0, y is equal to 1, and x is equal to 1, y is equal to 0, are the only two solutions that we have for the set of equations that we got from this problem. Before finishing this video, I would like to mention that the other possible approach to solve this problem is obviously to plot the graphs. However, I wanted to make sure that you understand how we will use our reasoning skills to solve this kind of problem. For now, let's focus on the graph. Here, the green graph is the graph that we have for x cubed plus y cubed is equal to 1. And the red graph is x to the power of 4 plus y to the power of 4 is equal to 1. As you can see that they intersect each other in only two positions, which are the locations that we found in the first part of this video. I hope you enjoyed this video. If so, please consider subscribing to this channel. This is the SQRT channel.